Good afternoon, ladies and gentlemen. My name is Chris Lambert. Today I'd like to talk to you about an exploration project that I worked on in 2016, 2017, the Al-Masani polymetallic project in Saudi Arabia. A little bit about myself. I'm an industry exploration geologist with 6 years industrial experience, mainly focused around exploration geology and resource estimation. I work for the company SLK. We're a global mining consultancy, and we also deal with geotechnical and mining engineering, mineral processing, tailings and waste disposal, as well as water management and environmental and social impact assessments. So the project itself is located in southern Saudi Arabia, about 60 kilometers north of the Yemen border, and it's run by the company AMAC. The license occupies about 42 square kilometers of mountainous desert environment and is about 2,000 meters above sea level. We were based where the yellow star is in the Al-Masani mine site. So this is a historical mine that was worked underground, closed in the late 1990s, and AMAC had picked up this license, so we're looking to rejuvenate that mine and reopen it. The access to the license area is mainly by sealed road, marked here in black, with dirt tracks leading into the license area. Unfortunately, Wadi floods had sort of washed a lot of these out, and so the majority of the license had to be accessed on foot. As you can see from the image here, it's quite a rugged environment, so heat stroke, dehydration, and trips and falls were all risks that had to be managed at the time that we were doing this project. SLK had a large scope of work for this project, ranging from grassroots exploration all the way through to underground mapping, underground drilling, and resource estimation, mine development. But my personal involvement in this project was to look at the mineralization at the mine and then look for analogies outside into the wider license area to try and identify further mineralization. A bit about the regional history of this area. So the rocks are typically Precambrian, dating from about 900 to 700 million years ago. They were deposited in a marine setting, and we know this because we find things like pillow basalts, as well as grey shales, so the original muds that were deposited at the bottom of the ocean. And there's a lot of volcanic rocks there as well, large packages of felsic to mafic tuffs. The mineralization that we were looking for was volcanogenic massive sulfides, or VMS, and this is just a fancy title for ancient black smokers. Typically, we were looking for copper and zinc mineralization with varying amounts of gold and silver. About 700 million years ago, we get the onset of the East African orogeny. This is where we get West Gondwana and East Gondwana, these two land masses coming together, thrusting and pushing and folding all of the oceanic sediments and base rock up into a mountain system, and then also getting crustal melting, which is developing these granitic plutons coming up through the crust, about 660 million years ago. There's a satellite imagery of one of these granites. It's the outline of it, and it's about 4 kilometers in diameter, so it's a fairly large intrusion. We start to get a substance of the orogeny about 640 million years ago, and following on from that, we get erosion of this mountain belt. We then get the deposition of the Arabian platform sediments at about 540 and 440 million years ago, unconformably overlying these Precambrian basement rocks. During the Triassic, related to the Red Sea rifting, we get basaltic dikes forming, and this is an image here of what they look like in the field. They're only a few meters wide, but they extend laterally for several kilometers. They're very obvious. And then finally, further uplift and erosion brings us to the present day, where we can see an example here of the Wajid sandstones, which are flat-lying and unconformably overlying the Precambrian basement rocks. The type of mineralization we were looking for, as I say, it was a VMS style, so we're looking at these massive sulfides, and then at surface, where they come into contact with the surface, they begin to weather, oxidize, rust, forming gossans, and that was the main target that we were exploring for. In addition to that, we also find disseminated sulfides in some of the areas. This is just where we got metal which is interspersed throughout the host rock, as well as exhalative beds as well. So these form on the flanks of the VMS mineralization, and they're just a key indicator that we're getting close to mineralization. So how did we actually go about exploring for this stuff? Well, we started with a desktop historical data review. So we had about 50 years of discontinuous exploration and mining data. It included about 700 rock chip samples from across the license area, over 600 drill holes, mainly from underground workings, but some from surface as well. And also, we were provided by the client with about 10,000, nearly 10,000 digital files, which all had to be sorted through. So it was quite a big job just going through the original data. As you can see, we got some beautiful hand-drawn maps from the 1970s. These were a pleasure to work with. They were lovely. They were great. So we took all the historical data, we combined that with satellite imagery, and then we also did some multispectral analysis looking for iron oxide and clay responses, which may be indicators for VMS mineralization. We came up with 17 historical prospect areas based on the work that had been done over the last 50 years. And we also came up with 17 remotely sensed target areas. The historical areas are marked in blue on this map, and the remotely sensed ones are marked in purple. As you can see, there's a good correlation between these. So that gave us confidence that what we were looking at in the multispectral data correlated well with the historical mapped gossans. What was interesting was there was a few areas which hadn't been mapped historically that came up with some anomalies. And when we visited these in the field, we actually found 3 new gossan horizons. So that was a really good result for the project. Mapping was completed over a period of 3 months. We started off by doing confirmation mapping, looking at the historical maps and data, validating them and checking that we were happy with their interpretation. And they were great, they were fantastic, so we were able to use those. We then started to map further into the license area that had been previously unrecorded. We did detailed mapping over all the prospect areas at 1 to 1,000 and 1 to 2,000 scale, and then we used all the information that we'd collected to produce a 1 to 20,000 scale map. As you can see, we had, in some cases, over 90% exposure, so getting lost in the detail was a real challenge for us. So, especially when you start to find these gossans, it's a really nice area to work in. So when we collected that data, we started to consolidate that and interpret it. So we pulled in our geological findings, combined that with the satellite imagery and the historical data, the detailed mapping over the prospects, and then we came up with our final interpretation. And this is an example of the map that we presented to the client. It's actually on the board outside if anybody would like to have a closer look as well. So some of the outcomes. As I say, we found 3 new gossanous horizons and also 2 newly found strike extensions to previously known mineralization. These need further work to obviously quantify how much material is there and whether they are reasonable mineable targets. But it just shows that the area is still prospective for further mineralization. In addition to that, based on the rocks that we found within the license area, we identified areas to the north, the south, and the west, the same rocks outcropping, and we recommended to the client that they pick up those license areas and that they look to explore those areas in the same manner as they're doing with the Al-Masani license. And finally, we also identified the fact that a lot of these targets may be buried. This is an example of the Moith gossan. We have a small outcrop, let me see if I can get this to work, there we go, in a road cutting here, and about a 40 centimetre wide gossan, 200 metres up the slope. There's no observable surface mineralization connecting these 2 outcrops. However, we were lucky enough to go underground and go and have a look at this at depth, and this actually blows out to about 20 metres width, and this is one of the highest grading deposits within the license area. So this just goes to show that buried deposits really are a tangible target for this mineralization, and we had to consider that when recommending further exploration work. So we recommended flying airborne magnetic and electromagnetic surveys. This would be to try and identify broad areas of potential targets, either at surface or at depth. Once you've identified those, you can then do ground-based surveys to try and quantify those areas a little bit more, try and narrow in on them, followed by trenching and drilling. And then eventually we can also do downhole electromagnetic surveys to vector towards buried targets. The project today, the mine reopened, which is fantastic. It was really good to work on this project with these guys. It was a fantastic team of exploration geologists who are currently looking in to develop the targets that we identified further, as well as the mining engineers and the mine geologists as well. I'd just like to say thank you very much to AMAC for allowing me to present this talk, and also SRK for all their support whilst doing this work. Special thanks to James Williams and Harry Rees. They were my mapping partners and my partners in crime, so it was quite they put a lot of hard work in as well for this project. Thank you very much for listening. Cheers.